Building an infrastructure has more options than ever, but managing deployments with automated systems and doing it securely? Join us as we talk with 2 Sigma about how they made it happen on this episode of Stack Chat. Thanks for joining us, Nick. Tell us a little more about 2 Sigma and how you manage your deployments.
Sure, thanks for having us. At 2 Sigma, we combine data science and technology as well as financial expertise, and we use that to develop sophisticated trading models. These help us uncover value in the world's markets. As you can imagine, this requires the right balance of allowing multiple stakeholders and researchers to iterate on research pretty rapidly while still protecting authorization and controlling our IP.
Can you show us what that looks like?
Sure, so this isn't an exact representation of our specific environment, but it's a good abstraction that we can use as a baseline to talk about from. So we started out with just some super admin identities, and then we decided to extend our on-premise existing source of truth for identity, which in our case is LDAP, to Google Identity, and we used Google Cloud Directory Sync to do that. Then we use identity and access management policies to restrict who can access Google Cloud resources. This includes things like Google Cloud Storage buckets, compute instances, other services, BigQuery, a few others.
How do you lock down the permissions for these new resources?
We created pretty granular identity and access management policies so that we can limit who has access to resources. And we also heavily restrict things that we consider privileged operations. So for us, that's anything that could impact the security posture of a project, like IAM changes or changes to the virtual private cloud structure, Google Cloud Storage bucket permissions or BigQuery dataset permissions. We control those pretty heavily. Further to that, only 2 Sigma employees have access to our resources. We don't share with any external parties. And we set up specific role-based access controls even within our organization, such as only granting the public cloud engineering team and reliability engineering teams access to manage compute engine instances. We mandated security keys and 10-minute session timeouts for our super admins. As you can imagine, those are very powerful accounts and we want to protect them accordingly. We also took a step where we blocked virtual machine images from being shared between projects, because this was another control for us to prevent exfiltration of our data from potentially a more secure production environment to a development environment that's less locked down. Finally, we use VPC service controls and specifically the secure perimeters product to protect data in locations such as Google Cloud Storage and BigQuery at the API level. These policies together let us secure access to our resources, and they're pretty easy for us to edit and iterate on as we implement additional policies or as we decide to change our security model.
So that secures the users and some of the data, but what about the network?
All of our virtual machines are launched in virtual private cloud environments, and this helps keep them segmented and segregated at the network level. We use organization policies and firewall rules to limit access from anything outside of the VPC to hitting those hosts. Of course, we had to connect the VPCs to data sources in our internal data centers to enable kind of research workflows and modeling, and we used private interconnect to do that. This communication also enabled accessibility to our internal Kerberos infrastructure, so we use that to handle system authentication and authorization at the operating system layer the same way we would on-prem. Gives us a unified authorization model. To further lock things down, in all of our VPCs, we remove the route to the internet so that no external resources can be accessed from inside of the VPC by a compute instance. In some very specific projects, we also used identity-aware proxy, and this helps us authorize a subset of our researchers to access specific isolated resources in our GCP organization in a controlled and secure manner, but still allowing them a little more flexibility in their workflows.
It sounds like this was a really iterative process as you locked down different portions. If you knew now everything you learned throughout, what would you do differently?
We created a lot of tech debt through duplicating our efforts in our early exploratory initiatives. So you can imagine we had a bunch of different projects that we'd set up individually. Each of them had their own IAM policies, organization policies, and private connectivity configured. We'd gone through a lot of different measures for connectivity. So we started out with public peering, then we moved to VPN, and finally private interconnect. But we duplicated this infrastructure across each of those distinct projects. And this led to a lot of complexity and management overhead. And as you can imagine, as you add projects, this just increases exponentially, and we were kind of tripping over ourselves. So in hindsight, I think at an earlier stage, if we decided to architect for shared services a lot more, using things like a shared VPC, using policy inheritance, all things that trickle down from the organization level, I think we would have been in a better position to build firm-wide platforms that could be reused by multiple teams and multiple businesses much earlier in the process. And this would have saved us a lot of effort and complexity, and we would have been able to iterate even faster than we do now.
Thanks so much for sharing your security journey.
Our pleasure.
If you'd like to learn more about setting up IAM policies, including setting them at the organizational level, check out the link in the description.
Thanks for watching, and make sure to subscribe for more great Google Cloud Platform content. We'll see you next time on Stack Chat.